Hey Calculus Kids, this is Dr. Callahan with week 15 Tuesday. How are you guys doing? Go ahead and pause the video and answer the following 3 questions for your warm-up log. Okay, so today you guys have a piece of paper that this is the front part of it and this is the back part of it. So we're going to go ahead and get started with a free response question. This is the first one that we have, so I'm going to give you guys a second, pause the video and review the question. There are 4 parts. Okay, so you have the differential equation right here. For A, on the axis provided, sketch a slope of the differential equation at the 6 different points. So as I'm looking at this part right here, I can see that for part A, my dy over dx is my slope, which is going to be 2x minus y. So you're just going to look at the points here, which is going to be at 0, 2, 0, 1, 1, 2, 1, 1. And then here it's going to be 0, negative 1, and 1, negative 1. So remember, these are the x, y values. So once you have that, you're just going to plug it into the 6 different points. So when my first point is at 0, 2, my dy over dx is going to be 2 times 0 minus y, which is just a negative 2. So at this point here, it's a slope of negative 2 over 1. So think of it as going down 2 over 1. So it looks something like that. Then you have 1, 2. So your dy over dx is equal to 2 times 1, which is 2, minus 2 is 0. It's a horizontal line. So on this point, it's just a horizontal point. Next point you have is 0, 1. So your dy over dx is equal to 2 times 0 minus 1, which is a negative 1. So at this point, you're going to go down 1 over 1. So it looks something a little bit more flatter than the previous one. Then your fourth point is 1, 1. So your dy over dx is going to be 2 times 1 is 2 minus 1. So 2 minus 1 is just a 1. So that's a positive 1 slope. Fifth point that you have is 0, negative 1. So 2 times 0 minus negative 1 is a positive 1. So that's also a positive. And then your last point, dy over dx is going to be 2 times 1, which is 2, minus negative 1, which is going to be a 3. So that's up 3. So from this point, 1, 2, 3 over 1. And so it looks something like that. Okay, so that is what your diagram should look like. If you take a look at the points here, you get 2 points for part A, where x equals 0, where x equals 1. So that's actually not too bad. That was fairly simple for the most part. Now let's take a look at part B. For part B, it says find the second derivative in terms of x and y, determine the concavity of all solutions and curve for the given differential equation in quadrant 2, and give a reason for your answer. So looking at this part here, you know that your dy over dx is equal to 2x minus 1. So your second derivative would be the derivative of 2x, which is a 2, derivative y is 1, dy over dx. While you know dy over dx is equal to 2x minus y, so I'm going to replace it there. So 2 minus 2x plus y, which is the same thing as, well, 2 minus 2x plus y. So that is going to be your second derivative. Okay, so then looking at this part here in quadrant 2 is where? Let's put it here in quadrant 2. This is going to be quadrant 1, quadrant 2, quadrant 3, quadrant 4. So specifically, I'm looking in this section here. I'm going to say quadrant 2 is where x is less than 0, because that's true. And y is greater than 0. So therefore, dy squared y over dx squared is equal to, or is going to be greater than 0 for all solutions. And what that means is that d squared y over dx squared is greater than 0 indicates the solution. And if you think about second derivative, which is greater than 0, so anything with a second derivative, you're talking about concavity. And if it's greater than 0, then what that means is that they are concave up. So the solution are concave up, since dyy over dx squared is greater in quadrant 2. And that's something that you can just go ahead and indicate that way. Okay, so then moving on to part C. It says let y equals f of x be the particular solution to the differential equation with the initial condition x equals 2, y equals 3. Does f have a relative minimum, maximum at neither x equals 2? Justify your answers. Well, for part C, given that you have dy over dx is equal to 2x minus y, and you have the point 2, 3, this is going to be the slope, then dy over dx at 2.3 is going to be equal to 2 times x, which is a 4, minus y, which is a 3, equals 1. And this is not equal to 0. So what you can say is, since dy over dx is not equal to 0, y is equal to f of x has neither a max or min, because the first derivative of x equals 0 is the critical point to test for max and min. And you can say if it's a max, if the slope is going from a positive to a negative, and then of course, if the slope is going from a negative to a positive, that will indicate a min at 0.23. All right, so for the last part, all right, so for part D, find the value that's constant m and b for which y equals mx plus b is a solution to the equation. So you have your slope, which is dy over dx equals 2x minus y. And of course, you want your equation to be y equals mx plus b. You know that dy over dx is slope. So m is equal to 2x minus y. And I can solve for y by writing y is equal to 2x minus m. And so looking at this part right here, let's take a look. I have 2x minus y equals m. So then what is y equal to? I'm given that y is equal to this part right here. So then 2x minus mx plus b equals m. So 2x, distribute the negative, negative m x minus b equals m. So then I will have I now need to go ahead and figure out what is going to be my B value. So with my B value, I will have Y, which is going to be equal to right here, 2x minus m equals mx. Minus b. So I have 2x minus m times x minus b, which is equal to 0x plus m. So let's go ahead and distribute the x here. So then I'm going to have negative, or excuse me, positive 2 minus m equals 0, which means that m equals a positive 2 as my first part for m. And then second piece, negative b equals m. So then b equals positive b equals a negative m, which is a negative 2. So then you do have the solution y equals 2x minus 2. And that is your answer. All right, you guys, after this, what I want you guys to do is you have another question on your paper that's very similar to the one that we did. I have the answers right here, but it is kind of flipped backwards because I want you guys to give it a try on your own. And then when you're done with that, go ahead and go to the Google form right here. It says, what are your plans post high school? There are several questions here for you to answer. The QR code is right there, or you can type in this green tiny URL. All right, as always, have a wonderful week. I'll see you guys next time. Take care.